then we could go into like each of those components, and there's just so much red meat there. Speech recognition, I hinted at before, like one of the things that's really challenging is you got speakers, many languages being spoken, sometimes simultaneously, or like rapid switching, like code switching and kind of polyglot conversations. You're going from one language to another. You also have just like a wide variety of noise conditions. You have noisy backgrounds. You have people who are starting to use like emergency department, where there's all kinds of chaos going on and background beeping and machines. You have people using it in outpatient settings. You have people with interpreters in the room, people with parents in the room. But then this other problem is staying current because things aren't fixed. So we use before we took control of our own destiny with speech, we were relying on third-party speech recognition. And the problem we kept running into is like the available systems have no coverage at all. We're talking about like 4% accuracy or something like this on novel medical terms that were introduced to the vocabulary after the cutoff date for their data sets. So if you go on, like, I won't say which, you go on some like cloud provider speech recognition and you say COVID-19, it gets transcribed as Cobra-19. And you say like there's all these new drugs, the semaglutides, that are really popular for they're originally designed for like diabetes management, but have become popular weight loss treatments. And these are like, you'd be shocked at how many different ways you could misspell Wegovy or Ozempic. Like Ozempic could become Olympic, Ozempic. So figuring out how to deal with these kinds of problems where, and we do all kinds of things to get around this. A ton of it, I'm thinking about like what I could say, without running it by, broader consensus for what I could share. But I'd say that there's sort of like a couple sides to how we're able to do so well on these kinds of terms. And one is the way we're dialed in on feedback. We have really precise feedback coming in. Like our doctors are dialed in, and because we're able to process and act on feedback about what's being misspelled where so fast, they often feel like when they type in their feedback forms that they're typing to the AI. To the point that like if they are like, oh, this thing, I saw this thing at like noon, and then if it's like it's not fixed by 2 p.m., they're like, didn't you hear? Like, did you get my last message? And then the next day they'll check in and it's fixed, and they're like, all right, thank you. And so it's not exactly that like the abridged brain is reading the comments and self-improving exactly. But we do have we've designed pretty sophisticated internal business processes for capturing that information, for acting on it really quickly. And we have primitives that facilitate that. On the other side, we're able to do things like pull all the new drug names, new disease names. We're able to find out like what they are, to use them in context, to ultimately like create a view for our model where it's as if they had been around and they are encountering them in the course of training. So, one problem is that if you have a word that has never occurred before in a data set, it's like you're doing like think of it in like Bayesian terms, like you're inferring a posterior, but like you've assigned zero prior to this being a word. So like the likelihood that it's a word conditional input is also zero because like the prior is zero. And so a big part of what's important is like, it's not even like the data being perfect, but it's like being able to get a model that's otherwise amazing to have some context for having seen these words before. And we're able to do a lot on that front. So all this work makes ASR much better. The LLM space is a really exciting one, and it's one where there's a really complex interaction between like what can we do with our LLMs? What are capabilities that are already really strong in general purpose LLMs? What are the places where the real path to progress is learning from like in vivo sort of human feedback, whether it's in the form of doctors' edits or Likert scale ratings? versus where we're able to um, move in other ways, use other kinds of engineering techniques. And there, I'd say that at a high level, um, our kind of first commitment to always is to ship the best possible product. And that means that like the exact, it's not like there's like we're married to one method and that will be what powers every single component of the system. It's like we will ship the best top to bottom product that we possibly can at any point in time, and we will continue to iterate on all those things. And I kind of call this like my like philosophy on it when I evangelize it with the company is like you need to earn the right to be elegant. Like if there's something like you need to earn the right to be elegant, you need to earn the right to be proprietary. Um, you need to like you get to ship your model when your model is the best thing in the world. That's like the best thing at our fingertips. And if it's not, then you don't get to. And that sets a culture because you can't you can only have like one first commitment. Like your first commitment is either to quality or your first commitment is to like I'm prideful about this thing that I built, and it can't be both because sometimes like they'll come into conflict. um, and I think by making everything quality first, it set the tone and it set a standard that everything like when did we switch from third party speech recognition to our speech recognition? When it was undeniably better, faster, cheaper, more accurate, better out of sample, better on new medication domain, and not a moment before. And I think that like that's been the kind of attitude that we have. um, there's something I think there's overall like a workflow emerging that's really interesting, which is that I think there's this whenever you're like going after a new use case or a new behavior, there's like this product discovery phase where you're like developing a new feature, but it's not like oh, just like train on the data. There is no data, there is no ground truth. Like you're going after something where like you're really like the mediator between many stakeholders, like helping to try to like tease out like what would doing this task really well look like. And the data that even exists doesn't fully live up to that, even if the doctors are amazing or whoever's the other stakeholder, like a case manager, because they haven't had the time to be able to make perfectly polished notes. They're like falling short of their own standards because you've given them like 15 minutes to write 2 pages. Like imagine what your prose would look like in that context. So we're often in a situation in the LLM space where we're able to take full advantage of like the rich toolkit that's provided by general purpose LLMs to get in the neighborhood, get in the ballpark of a behavior, be able to iterate with stakeholders and find out like, are we even like get the shit pointed in the right direction. And then once you are, there's so many ways to learn from there because you're learning from feedback, you're learning from edits. And then this becomes this engineering project that moves in a different direction and often is best served by proprietary models. But I think there's these incredible strains of controlling the model top to bottom because of all the different granular control that you have over what's the learning objective, what's the training data, how are you steering that model, and at the same time, there's this incredible like generation shifting ability to get off the ground that is provided by some of the general purpose LMs, and by having like sort of that full spectrum of competencies, we're able to do kind of have like the best of all worlds. And that's sort of like the playground that we're working with. Now, linked evidence is an entire other beast for how we accomplish that. But that's I think the amazing thing is that like as a data scientist, as a machine learning scientist, a fear in going into a startup is like maybe um, they're talking about AI, but like once you get deep into the weeds, or once you finally like pivot 1, 2, 3, 4, 5 times and find your PMF, maybe what you're doing is like machine learning is not the important thing, and then like what are you doing? And I just feel like incredibly lucky to be in a place where we are building something that like I believe in from a mission standpoint, but also where you know as a pragmatic or as a kind of like application oriented scientist, the richness of the problems like every day is kind of like being a kid in a candy store.
Yeah, two things from that amazing section describing all of the data science things, the key things that excite you about what you're up to at Abridge. Two things that I really want to highlight are this idea of being committed to providing the best quality models. So it's so easy for an AI company to say, okay, we're an AI company, we're going to roll out AI models, even if they're not the best, even if there are existing LLMs out there or cloud provider models or third-party models that could be used instead. So I love the comment that you made about earning the right to be elegant, earning the right to have a proprietary model in production only when that model is definitively better in terms of capabilities, cost, et cetera. Um, that is I think that's a really great guiding principle to have in your company. The other thing that I wanted to highlight from everything you just said that I thought was one of the funniest things was consumers' expectations when you are an AI company. So the physician in the hospital network that is bought onto a bridge, that physician knows that a bridge is an AI company. And so it's so funny to me from a data scientist perspective, and I'm sure from many of our listeners' perspective, that you could be chatting with the AI and the AI is like understanding what you're saying and adapting its code and model weights to deal with the situation that the physician is complaining about in these messages. Why haven't you done anything about this?
Yeah. But it's wild, it's crazy and it's not crazy, right? Because you're like, on one hand, like day one, um, we had this feedback channel. I think we were maybe like smart about setting up in a way where it really directly informed product development. But also the only process day one for ingesting it was, well, also because day one you've got like the 10 users at your first pilot or something, uh, is hawkishly reading every single comment that comes through. And I still read almost every comment. Like I'll read thousands of them. I'm addicted to it. Like I'll drink from the fire hose. But at some point you get into a world where it's like this is no longer a set of particles. This is a wave. And at that point, it, it makes sense to in addition to the fact that like I think you can never stop reading the prose because there's nothing like what that does. Again, it's like the things the sensory apparatus you'll build on top of a comment stream will detect the things that you know are issues and the things that you know are like axes of the conversation. They won't tell you what are the things that you never thought to develop a sensor for. Um, so um, so we still read, but at the same time, for all those things that we know about, like we are able to start making a certain kind of programmatic sense of the comments. So having like at the point where, in addition to the fact that we're reading constantly the comments, there's also the ability to start turning this stream of data into um, a real time kind of indicator of what's going on. And at that point, you're like, okay, like it's not necessarily that there is this one monolithic like artificial brain called the AI that is at once serving the note and reading the comments, but you have an AI system that is reading the comments and an AI system that's sharing the notes and the various processes by which these things can be coupled through the process of like model training are like that is like not it's not so while it's not so conceptually removed from their picture as to be like it becomes less and less goofy, like the idea that like you're like the AI is reading it. At the same time, I think something that we have to be very careful about is I think a lot of people might not appreciate the like when we're in academia, I think it's very popular to think about like online problems, and you're just like, oh, a datum comes in, and then stuff happens, and then the model's updated, and then the next datum comes in, the updated model does something on whatever, and then everyone who's actually tried to train a complicated model knows how just like when you're making updates to models, like all bets are kind of off and like anything can happen. You can't when quality rests on a certain kind of rigor in evaluation, you can't just be like willy-nilly making updates to weights at like whatever cadence you want. And so you wind up in a situation where like there are all these signals coming in and they are influencing behavior, but it's on a different kind of cadence. I think OpenAI has been a great pioneer here, and I really admire like how creative they've been here. It's what they're doing, and this whole discipline that they've pioneered in the space with ChatGPT and learning from preference feedback. It is something that at once on a technical level looks nothing like reinforcement learning. Like you're not like, I got a state, I chose an action, I received a reward, I transitioned to another state, and let me do some kind of Bellman update. It looks nothing like that, but the spirit of what they're doing is very much like reinforcement learning, and that like the core can, like, if you're not thinking as a technician, but you're thinking as like a philosopher, the core differentiator between reinforcement learning and supervised learning is this: am I learning from exemplars or am I learning from evaluative feedback? And the crazy thing about evaluative feedback is it allows you to continue to improve in a world where nobody knows what perfect looks like. It allows you to follow um, the reward signal, and in a sense, what OpenAI has figured out is that, hey, you could build these absolutely wild systems, these absolutely wild action spaces, and learn from evaluative feedback, but it's not on the cadence of like every update you get, I'm improving. There's these longer windows of collecting data, a much longer process in the background of figuring out how to learn from it to get to the next checkpoint, of deploying that, of collecting more information, of people finding out, do they really find it better? Do they transition? Does that next checkpoint not actually gain traction and they kind of got to rewind and start from somewhere else? Um, it doesn't have maybe the smoothness of like academic RL, but it has the spirit of it, and it is doing it on a scale that probably nobody, you know, it's unlike like when has someone built a system like that impacted so many people and that learned from evaluative feedback so effectively.